All right, here we go. We have 2.2a, and what we're talking about are density curves and normal distributions and the uh, empirical method. And so what we have is a problem with circular understanding where it says an internet reaction time test asks subjects to click on the mouse button as you see the lights flash on the screen. You can read the rest of it, and it says the density curve models the amount of time the subject has to wait for the light to flash. And so the first part is the height of the density curve must have what? Justify your answer. So what we have right here is a distribution, and you can see this distribution is going right here, and it's uniform. All right. And to be a density curve, if you recall, density curves have an area that is equal to 1. All right. And so since we have this area right here, and we know the length from here, from 1 to 5 is going to be 5 minus 1, which is 4. Okay. The area, we would take this width, all right, times this height. And so it's going to be 4 times some sort of a height, and that has to equal 1. And so we can obviously see that the height has to equal 1/4, and for this area to equal 1. And so the height is equal to 1/4 because the area under distribution must equal 1 because it is a density curve. All right, now it says about what percent of the time will the light flash more than 3.75 seconds? Okay, I'll change my color and it's right here. All right, well, 3.75 seconds is looking about right there, and we're looking for more than that, And so we're looking for this area right there. Now to find that area, we're going to take this length, which is going to be 5 minus 3.75. Okay, and when you have that length, you can see that's going to equal 1.25. 1.25. Well, to find that area, okay, we know that area is going to equal 1.25 times our 1/4, because that's our height. And so we put this in our calculators, and then you're going to have a value of approximately 0.3125, which equates to, all right, 31.25%. Okay, so that's what we have there. So 31.25%. Now the next part says calculate and interpret the 38th percentile of the distribution. All right, the 38th percentile of the distribution. Now the 38th percentile, I'll change the color one more time. All right. The 38th percentile is going to equal, well, 0.38, okay, pi, or is going to equal this width, all right? Now, if you notice this right here, okay, what we're going to do is we have to figure out this length from here to there, okay? And so the value we get is going to equal 1 plus, all right, some sort of value, okay? And I'm just going to call this value x because I like algebra, all right? And that's going to be multiplied by 1/4. Okay, that's going to be multiplied by 1/4. All right, and so what we have here, okay, is this value right there that we can find, all right? Maybe I'll just erase that, okay? Is the value that we find is going to be, all right, well, what we have, all right, finding first off the area, looking for, okay, times 1/4. And so if we take 0.38, all right, times 1/4, is going to equal this x value of 1.52. 1.52. Now 1.52 is right here, but we have to add 1 to that because that's where like our x value, we have to add 1 to our x value. All right, and so our actual total length that we want is going to equal right here, okay, which is going to be approximately, right, 2.5 Okay, so I have to make this out a little more. All right, and so that, my friends, all right, is the area we're looking for, and that is going to be 38%. So what do we have? All right, 38% of this distribution in distribution of time, of the distribution of time is 2.52 seconds or less. Okay, so 30% of the distribution is time or less, and that's what a percentile is. Okay, next, moving on, all right, and so we have then is the distribution of height of young women aged 18 to 24 is approximately normal with a mean of 64.5 inches and a standard deviation of 2.5 inches. Sketch normal curve and approximate distribution of woman height. Label the mean and the points that are 1, 2, and 3 standard deviations from the mean. Okay, so our normal distribution, we're going to go like this. This is going to be our normal curve. Okay, and what we have with this normal curve, we're going to label this n. All right, being normal. And we're going to say 64.5. So I'm going to label this, and then 2.5. And so when we have right here, this first part is going to be 64.5. All right, and these are in inches. Okay. All right. And now we're going to go one standard deviation away. Okay, one standard deviation away. And we'll just say that's one standard deviation away. All right, and this is going to be one standard deviation away. Now that one standard deviation away is on average going to be 2.5 from the mean, all right, on either side. And so we're going to take our 64.5 and we're going to add 2.5 to that, and we're going to have 67 inches. And then we take our 64.5 and we subtract 2.5 from that, and then we get 62 inches. Well, now we need to go the same length away, and that's going to give us our, all right, second standard deviation, okay? Right there, okay? And so we're going to take 67, and we're going to add, or we're going to have right here, if you add 67 plus 2.5, you'll get 69.5 inches. And then if you take 64.5, sorry, you take 62 and subtract 2.5, what you have is 59.5 inches. And so this is going to be 2 standard deviations away from the mean. All right, 2 standard deviations of the mean. Okay, and now we're going to go one more, and right here, and about right there, there's going to be 3 standard deviations away from the mean. Okay, 3 standard deviations away from the mean. And so we're going to take our 62, our 69.5, and we'll add 2.5 to that, and we'll get 72 inches. And then we'll take 59.5 and subtract 2.5, and we'll get 57 inches. All right, and so each one of these, all right, how do we get this? Well, this is going to be our mean plus 1 standard deviation. This is going to be our mean plus 2 standard deviations. This is our mean plus 3 standard deviations. And then over here, when we get this one, it's going to be our mean minus a standard deviation. It's going to be a mean minus 2 standard deviations. And this is our mean minus 3 standard deviations. And so we keep on taking those standard deviations from there. And so that, my friends, is how we can sketch the normal curve and approximate the distribution of the young women's heights, all right, like that. All right, well, I hope this check your understanding. First one helps you out on how to understand density curves, how to calculate and interpret percentiles using the density curve, and also how to create a normal distribution. All right, good looking. God bless, and the rest of your problems.